Okay, so pedigrees. Pedigrees, just some quick information that you need to know. Anytime you see a square, those are referring to males. If the square is unshaded, that means they're normal. If it's a recessive trait, and if it's shaded in, it's disease because it's a recessive trait. Females, you are circles, and then if it's shaded in, it is diseased. What you'll notice here is a line connecting the two means they've mated, and then the line down and anything that is attached to this horizontal line means it's a child. Other things we have here are Roman numerals to number the generation. So this is the first generation. There were 2 people in it. Generation 2, there's 8 people in it. And generation 3, there's 5 people in it. So this will kind of get explained as we go on. So it's asking us here, which members of the family above are afflicted with Huntington's disease? So how we write this is we usually write the Roman numeral, and then we do a dash, and then whatever number. So if they are afflicted, that means they're shaded in. So from the first generation, the first person, so it would be Roman numeral 1-1. Okay, generation 2, who is shaded in? Person 2, 3, and 7. So we can actually separate those by commas since they're in the same generation. And then Roman numeral 3, number 3. So those are all the people who are shaded in. Now there are no carriers for Huntington's disease. You either have it or you don't. With this in mind, is Huntington's disease caused by dominant or recessive trait? Since there aren't very many shaded in, that would lead us to believe that it's a recessive trait, because if it were dominant, then more people would tend to be shaded in. Now it asks us, how many children did individuals 1, 1, and 1, 2 have? So 1, 1, 1, 2. So you're going to count out how many lines are directly connected to this horizontal line. So 1, 2, 3, 4, 5, 6. So our answer would be 6. Okay, how many girls did 2, 1, and 2, 2 have? So 2, 1, and 2, 2 wants to know how many girls. Girls, again, are circles. So 1, 2. And how many have Huntington's disease? So how many are shaded in? In this case, 1. Okay, how are individuals 3, 2, and 2, 4 related? So 3, 2 is right here by my finger, and 2, 4 is related by my pen. So this is her mom, and that's her mom's brother, so that's her uncle. So this to her uncle would be her niece. So this is an uncle and niece relationship. Okay. How are 1, 2, and 2 or 3, 5 related? So how are these two related? That would be grandma and grandson. Okay, so that's kind of how you read pedigrees. So if we go down towards the bottom, this is actually a word problem. So how we do word problems is you're going to draw it out, and you want to go line by line so that way it's easier for you to understand it. So it says one couple has a son and a daughter. Okay, so a couple would be a boy and a girl. Again, show the line for mating. And then you would draw how the children are read. So son and a daughter. Okay, another couple. Okay, so we have another couple who has one son and 2 daughters. Okay, so if there's another family, we tend to draw it the same way, just over to the right a little bit. Okay, so they have a son and 2 daughters, and everyone is still normal pigmentation. So then it says the daughter from the first couple and the son had 3 children with the son of the second couple. Okay, so they had kids, so we draw a line connecting them, and they had 3 kids. So we'll just do our 3 lines because we don't know what kind of kids yet. Their son and 1 daughter have albinism. So son and 1 daughter have albinism. So far everyone's been normal, so that's where everyone's not shaded in. But since they have a disease, they're going to be shaded in. Okay, and the other daughter has normal pigmentation, so she's just normal like everybody else. Okay, so that's pretty much your pedigree. Now what you need to do before it's done is you have to label your generations. So the first generation, second generation, and the third generation. And then you start labeling from the left to the right. Each person gets their own number. So 1, 2, 3, 4, that's all row 1. Row 2, 1, 2, 3, 4, 5. And then row 3, 1, 2, and 3. And that's how that works.